I dive into frozen waves where the past comes back to life. Fight fear for the selfish pain, it was worth it every time.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. We are seeking clarity, and perhaps we shall find it with our study of descriptive statistics, probability, and counting techniques. Perhaps we shall find it studying today quantitative data. Yes, let's seek out some clarity. And up here we have some examples of quantitative data, things that we can count. And we have, if you want to pause it, we have a nice little description of the difference between qualitative and quantitative data. Let's get to it, shall we? Recall that a quantitative variable or data is one which has a numerical value and is often called a numerical variable. So we think of it as numerical data. A quantitative discrete variable takes exact number values and is often a result of counting. So this is the difference between discrete and continuous. That's what we're going for here. For example, the number of pets in a household takes on a particular number. A shoe size, it doesn't have to be an integer. This is a good example. The variable could be a mixed number, a fraction, okay? And a continuous variable is one that is usually the result of measuring. For example, your weight is continuous. As you gain weight, you hit every weight within a whatever range from your least to your greatest weight. Time is continuous. Temperature is continuous. Height is continuous. Pretty much anything you can measure is considered to be continuous. All right, so how do we display discrete data? This is data from the opening problem on page 170, if you want to take a look at that. Okay, and so the number of pumpkins per plant, and we had 2 plants had 3 pumpkins, and we scroll on down here. Let's see, 11 plants had 7 pumpkins, 5 plants had 9 pumpkins. Okay. And there are many different ways that we can display this data. We're going to take a look at a couple of them. I'm going to move them up for us. We have a column graph right here that shows, okay, so the frequency is the number of times that we have number of pumpkins per plant, right? So here we had 6 pumpkins per plant on, it looks to be 7 plants. Get the same idea with what is called a dot plot. A dot plot, number of pumpkins per plant. Let's see, how many had 8? Well, we know that there's 8. That's a bad example. Let's go to 5. How many pumpkins, or how many plants had 5 pumpkins? 1, 2, 3, and we look up here, same thing, 1, 2, and 3. Okay. And also, we take a look at describing the distribution of a data set. How is the data distributed? This is what we refer to as a normal distribution, and we'll talk a lot more about that later. But what we're looking at here is the fact that many data sets show symmetry or partial symmetry about the mode, where the data occurs most, or is the mode, as you know. Let's make this dashed because I want to do something here. Let's change the thickness a bit, and I just want a regular old line. Okay, so if I were to take a line and just go right through the middle, we can think of symmetry as looking the same on one side as it does on the other. We can say data is symmetrical even if it's not perfectly symmetrical. Or it's a normal distribution. It doesn't have to be exactly perfect. All this one appears to be. But we think of it as symmetrical or a normal distribution if it looks something like this. Sometimes we have skewed data. we have skewed data, okay, like right here. This is said to be negatively skewed because it looks like the graph has been stretched toward the left in the negative direction, going to the left. So we say data that when we draw like a curve over the bars and has a little bit of a slope or a big bit of a stretch here, we say that is negatively skewed. And I always think of it as if I took like this normal distribution that's symmetric and I took my hand and I grabbed a hold of a, say it's a string, and I pulled it to the left, it would be stretched this way. And this just kind of stayed there. And the bars kind of shrank underneath. I pulled it to the left in the negative direction. That's negatively skewed. And if I pulled this to the right, I pulled the string to the right, it would look something like this, and it's positively skewed. So this right here, we think of as a symmetrical distribution. Pulling or stretching to the left is a negatively skewed distribution, and pulling or stretching to the right is a positively skewed distribution. The other thing that you need to be familiar with are outliers. Outliers are data values that are either much larger or much smaller than the general body of data. Okay, and I have some graphs here as an example. Like I have all this data that's kind of grouped together, and then I got this cowboy out here just hanging out. That's an example of an outlier. Maybe we took a poll about age or something, or the age of some people walking through the mall or whatever, and got a bunch of 12 to 14-year-olds, and then we got a 24-year-old. Well, this piece of data is comparatively not close to this group of data here. Test scores. Here's a pretty good example of an outlier. The bulk of the class scored, it looks like, between maybe like a 58 and a 100%. And then one person had a pretty bad day and scored a 10. This would be considered an outlier. Okay, so a lot of vocab, a lot of understanding needed there to get us going on our study. Hope you enjoyed it. With that, I'm going to say that I am out before we listen to foxes and we gain some clarity. Mathematics is my remedy, and I shall say that I am